This is my assignment one. In this, first we download the housing data from the internet. Then we call the function to see our data is downloaded and good for our local environment. Then we create a loading house data function. Then we call this function and store into the housing variables. And then we use the head function to see how our data look like. It will return first six rows of our data set with all the columns. Then we use the info function, which tells the column names, total number of entries, and the values, which is not null or null, and data types like float, object, and memory usage. Then we use this code to see the number of occurrences of each category. Then we use a describe function which provides us a statistical summary of all the numerical columns like count, mean, median, quartile values, maximum. Then we use the matplotlib library to create the histogram for all the numerical attributes to see skewness and outliers. Then we use the NumPy library and create a split train test function to divide the housing dataset into training and test sets with an 80 and 20 splits. Then this command displays the first then this command displays the first five rows of our train set data frame. Then we again use the matplotlib library to create the histogram histogram of all the variables. Then we use the skitlearn train test split function to split the housing data set into training and test data. This line of creates a new categorical column called income cat in the housing data frame based on the medium income. Then we create a histogram for the income cat. Then we use stratified shuffle split from skitlearn to split the house data set into training and test set while maintaining the same distribution of the income categories in both the set. After that, we calculate the proportion of each income category within the stratified test set. Then we remove the income cat from the strat train set and strat train test set. Then we create a copy of the shared train set data frame and assign it to the variable housing. Then we create a scatter plot to visualize the geographical distribution of housing data points. Then we again created scatter plot with using alpha equal to 0.1 to generates a scatter plot with adjusted transparency, allowing you to visualize the density of high data points more effectively. Then we also created again with more detailed scatter plot to visualize housing data with additional information called population and house values. So in this line of code, snippets calculates correlation metrics for the numerical features in the housing data set, including after converting categorical into numerical. Then in this line of code, we retrieve and sort the correlation values of all features in the dataset with respect to the median house values. After that, we create a scatter plot, a matrix plot to visualize the pairwise relationship among selected feature in the housing dataset like this, and then we again create a scatter plot between medium income and medium house value, which shows basically positive correlationship between them. Now we create three new feature in the housing data frame by combining existing column to derive additional insights. And again, this sort the correlation values between the median house value and all other features in the data set. Identify which feature have the strongest linear relationship. And after that, this will separates the feature of input variables from the targeted variable, which is median house value in the training data set to prepare for model training. Then demonstrate how to handle missing value in the total bedroom column by creating a modified versions of the dataset without row containing missing data for the specific column. There are the three options which I'm gonna skip. After that, there is one more demonstrate how to handle missing data in a dataset using the simple imputer with scikit-learn, which fills a missing value with the median of each column. Then we use imputer statistics, which provides access to the statistics that were calculated for each feature during the fitting process. And then we handle the transformation of missing values and prepare both the numerical and categorical parts of the dataset for further analysis and modeling. And then this code converts the categorical data into the housing data frame into numerical values using scikit-learn ordinal encoder. Then this ordinal encoder categories provides information about the unique categories that were identified and coded by the ordinal encoder. Then it uses scikit-learn one hot encoder to transform the categorical housing cat data into one hot encoded format. After that, this command converts a separate matrix housing cat into a dense numpy array. Then cat encoder categories, transform class, combine attributes added to add new feature to the data set. So this is basically uses a custom transformer class, combined attribute editor to add new feature to the data set. This code pre-processing pipeline using scikit-learn pipeline functionality. The pipeline is designed to handle missing values, add new features, and many more things to making it ready for the machine learning models. Then this code is creates a compressive data processing pipeline using scikit-learning column transformer to handle the both the numerical and categorical feature. It combines the previously defined numerical pipeline with the new transformation for categorical data.